Hello everyone. Let's have a discussion on S parameters today. So we'll start with understanding a parameter. Parameter is basically used to measure few things. So in our RF world, we use it to measure the RF energy. So what is this S parameters? Are there any other parameters? So why am I choosing this S? What do you mean by S? How do I use it? How do I use it to measure RF energy? How do I equivalently write it in equation form? Or if it is an application based for any of the RF component, how do I use it? What do I use it to measure? So all these things we will learn today in a very simple way. Before going to the parameters, let's understand what is a network. In RF world, a network is a device with one or more ports. So as we see in the diagram, so these ports can either pass the RF energy, it can absorb the RF energy, or it can reflect it also. So either it could be one port, two port, three port, or n port network. One port, an easy example is antenna. For a two port, it's filter, amplifiers. A three port network could be a directional coupler, mixers, and we will have n port systems also. To analyze this networks, so in diagram what you see, it's a simple network which has two ports. So for our discussion in the whole discussion today, we will only keep the network to two port system. So having these two ports, we see that we usually inject or pass RF signal usually to one port at a time. So let's consider that also. And this analysis of the network can be done for a wide range of frequencies, the RF, microwaves and everything. So port 1, there is an incident energy which could be transmitted through the port 2, or it could be reflected back also from the port 1 itself. Is this good? Should it happen? If it shouldn't happen, how is it that I can overcome it? And always we know that if we pass something from one port, it has to get transmitted to the other port. So how much is it getting transmitted? Is all the amount whatever I've transmitted through port 1 is getting absorbed and radiated again in port 2, or what's happening? How do I measure this? So measuring this gives me an idea about what is the parameters which is getting passed, or what is the energy which is getting passed from port 1 to port 2. Again, considering a two-port network now, we see lot of S happening inside this box. What I have put S11, S12, S21 and S22. What are these? So for a two-port network, it will always be in terms of 1 and 2s. Simple as that. So S parameters is, so I have spoken about these RF energies, which is incident, which is transmitted, which is reflected back. So all these are analyzed because these energies are scattered. When I pass it through a port, it gets scattered. So this scattering is measured in terms of whether it is absorbed, whether it is reflected back, or whether it is transmitted. So since it's all about scattering, so we call it as a parameter which is used to measure this as S parameters or scattering parameters. So as we see here, the green line, we have S11. S11 says, so I'm giving input at 1 and I'm checking the reflections at port 1 itself. Likewise goes with S22. Now comes the other two, which is S21 and S12. What are these? So when we see here, let's again consider a two-port network. Now I have introduced two more notations of A and B's. So A is always with respect to incident wave. B is always with respect to reflected wave. So A1 and B1 are incident and reflected waves at port 1, and B2 and A2 are the reflected and incident waves at port 2. So when we see here, S11 is the input A1 or an incident wave at port 1 and the reflections B1 at port 1 itself. That is S11. Likewise goes with S22 also. S21. So here we always have to remember that the first subscript in S21, the 2 is always the output port. the port where signal emerges. And the second subscript, the 1 in S21, 1, it says about the input port, the port where signal always enters. So if it is S21, input is 1 and the output I am checking at 2. Or the incident is at port 1, reflections I am checking at port 2. Likewise goes with S12 also. The input is at port 2 and the reflections are checked at port 1. So this is how we use to understand, and these are the notations which are used for a 2-port network. Likewise, we can do it for 3-port, 4-port and n number of port network also. So this is the basic of it. Well, having known how to analyze this, how to write a system of a 2-port network in terms of S parameters. So either in terms of any of the combination of these 4, S11, S12, S21 and S22. So what does it give me? So there are these I can relate it into either reflection coefficients or transmission coefficients. Reflection coefficients are something where it only relates with the same subscripts for input and output. S11, S22, S33. So what does it say? So this says the input match. So if I am considering a 2-port network, as we see in the example here for an amplifier, so I am giving input at port 1 of an amplifier and I am checking the output also at port 1. So this is like input matching. So what is this matching? So we always talk about in this RF world that impedance has to be perfectly matched. So for an example, if I give S1 and something like I am teaching or I am talking, how much am I understanding it? Do I understand whatever I am talking, or am I blabbering? Something like that. And there comes transmission coefficient. Transmission coefficient is given input at one port and you're checking the reflections at the other port, or in the transmissions in other port. So this is transmitted. So that is my aim, is it? I'm giving at port 1. Obviously, I need to check the output at another port. So in an amplifier here, so if I am feeding the input at port 1, so obviously if it is an amplifier, I'll have a multiplied version of this input signal in terms of gain. So I measure that in terms of S21. Yeah. And there is also reverse isolation. Reverse isolation is due to this input given, there could be reflections occurring through port 1 itself where I have given the input. So that is there. So reflections, basically what you are talking to yourself and how much have you understood. Transmission is basically what I am telling and how much have you absorbed. Yeah. Are there any reflections coming back? Because we usually tell in a general way, no, I'm not understanding anything, it's bouncing back. So that is my reflections which I'm getting since I'm considering myself as port 1. Port 2 is someone who is listening to what I'm talking right now, and how much are you absorbing and transmitting it, and which means digesting the whole information. Okay, now let's see how do I put this S parameters in matrix form in an equation. So like same thing, A1, B1 for port 1, A2, B2 in port 2. So if I write this, so obviously reflections is what I am looking for. So that will be my output with S parameters and the incident input A1 and B1. So let me consider only the equation for B1, which will be S11A1 plus S12A2. So now let's assume that there is no incident at port 1. Okay, that is no incident at port 1 means A1 goes to 0. In that above equation, when A1 goes to 0, I am left with B1 is equal to S12 into A2. Okay, and if I rearrange it, S12 will be B1 by A2. So that's how I got the equation in the first place. So the same matrix, put it in an equation form, see whether you are giving the input either at port 1 or at port 2. Depending on that, I can always get my equation back, which tells me for an incident wave of so much, how much is getting reflected. So that measures S12 is, so as I already told again, the first subscript is always the output and the second one is the input. I'm giving the input at 2 and I'm checking the output at 1. So it will be my transmission coefficient. Where do I use this? What's the application of S parameters? So as simple as if we consider an antenna, so many times we always check S11. So if you simulate an antenna, if you want to find out the first performance of an antenna would be the impedance matching. So I measure that with S11. The same equation let's consider. B1 is equal to S11A1 plus S12A2, and we will write the equation for B2 also, which goes as S21A1 and S22A2, right? So let's now consider that the input is only at port 1. So if I do that, A2 goes to 0. There is no input at port 2. So the terms which are related to A2 goes to 0. So I'm left with B1, which is equal to S11A1. B2 is S21A1. So S11 is what, which we already discussed, it's the reflection loss. And S21 will talk about insertion loss. So these two gives me a very good analogy when I'm designing an antenna. If it's a single element antenna, S11, for me, I will check that. So what should be the value of it? How do I relate to something called as return loss, VSWR, and how do I use that in a real-time application when I'm fabricating or testing an antenna in a VNA or something? So how do I check this S11? What is the value should I get which tells me that this value of S11 makes me tell that the antenna is perfectly working. So impedance matching is good. So these discussions we will have it in the next video. For now, my main intention was to explain what S parameters are, how do I represent it considering a two-port network. So in that, what are the incidents, what are the reflections? If I want to derive an equation, how do I do that with the matrix? So what is reflections, what are transmissions? Also, S parameters are complex values. It has its magnitude, it has its phase, and these reflection coefficients can also be plotted on Smith chart. So over the next videos, we will have a detailed study of Smith chart in a very, very, very simple way, which I have understood for my own research and teaching and everything. So we will do that. How exactly can I relate S parameters on a Smith chart, right from considering a characteristic line, transmission line, normalizing it, how do I represent it on Smith chart? So all those things we will discuss in our next coming slides. Well, we learned so much about S parameters. Now it is, why am I doing S parameters? So I know that we have to use S parameters because as I told you, RF energy is scattering. Yeah. So why am I using this? So S parameters, the usage of S parameters is analytically very convenient. It can be cascaded to calculate system performance. It's very easy to measure also, otherwise considering any other parameters. It's easy to measure the voltages and current. And analysis also gets simplified if I am considering a very complex microwave systems. And it can simulate circuits. So S parameters are used to simulate circuits like filters, which need not have the internal structure. I don't have to know the internal structure of a filter to analyze or having to find out S parameters. So that makes me analyze the complete circuit also with S parameters. So having known the advantage of this, now let's see what are the key reasons why am I not using Z and Y parameters in microwave circuits. It's very, very, very important. That's why it's very start also, right? Somewhere it's like we already would have learned our network analysis using Z and Y parameters. And why am I not using that in the RF world, RF signals? So measurement gets challenging here. So precisely measuring voltage and current at these high frequencies gets very difficult because of very small wavelength at that high frequency. And distributed effects in the circuit makes it very difficult for me to understand or to measure the voltage and current at every given point. And one more major thing is gets very instability. There is instability occurring when I consider an open and short circuit. So active devices always become unstable or also might get damaged when I consider open circuit or closed circuit. So calculating them using Z and Y parameters gets very difficult for me. Also, when I try to create this open circuit or short circuit, so in my microwave network or a system, this will lead to standing waves. So this actually complicates my measurement again if I have to do it with respect to voltage or current. Hence, we moved into scattering. So what is this standing waves? So standing waves usually occur with a phenomena of VSWR, standing wave ratio. We measure that. So we will discuss that specifically in the next coming slides. Well, I hope you have understood the S parameters, though it was a very simple logic, a very simple topic which I took to understand it in a very easy way. So what I want to conclude is S parameters, scattering, RF world, it's always about scattering energy which is being measured either in terms of absorption, reflections and transmissions. So if it's a two-port network, how do I consider? I have four parameters. Two parameters of them, S11, S22 are with respect to reflections, and S21 and S12 are with respect to transmissions. So if I'm designing an antenna, it could be it is S11 for a single element. And if it is an array of element, if I want to find out what is the coupling, what is the insertion loss and those things, then I will use S21. Okay, last is if I have a S parameter S12. So what does it mean? What am I telling? S12 is giving the input at port 2 and I'm measuring the output at port 1. Okay, hope you have understood. Let's discuss more about VSWR, written loss, and then move into Smith charts and much more complicated stub analysis and all. Thank you so much.